All right. Thank you for attending today. We're going to be talking about chapters 8 and chapters 9 for this particular segment. So let me share my screen. Okay. So again, chapter 8, managing quality. For this discussion, these are some of the things that the chapter outline we want to cover today. Quality is customer judgment, manufacturing quality, the service quality, quality planning, control, and development, ensuring quality in the supply chain, the cost of quality, who are some of the pioneers of quality, the ISO 9000 standards, the Malcolm Baldrige Award, why some quality improvements fail, and with that, quality. What really is quality? Quality is one of those 4 key objectives that goes into operations of any type of manufacturing or any type of business. It goes along with cost, flexibility, and delivery, as well as the operations. It's kind of cross-functional in nature, and it should be involving the entire organization. Even though operations does have a special responsibility to produce a product for the customer, it does take all the employees from top to bottom to ensure quality is not only inspected but built into every component, every part, every device that leaves a manufacturing process. But equally important, it's not just reserved for a manufacturing process. We can use quality in every business that you and I are involved in. And back in the 1960s is where it really got its start, when a statistics pioneer, Walter Shewhart, developed statistical control charts to maintain the amount of inspections that was required. And this really kicked off the term called quality management, which was expanded again to include the entire operation or the entire organization. Over on page 163, you see the operations leader, the Ritz-Carlton Hotel Company. A good read that kind of goes into to describe how employees can make a difference and how employees are empowered through this, what they call lateral service, that it depended upon well-trained and perceptive and motivated employees. So it's not just reserved for the senior management team. It's equally important for everyone within the organization. Quality. Here's a good example of Comair Flight 5191, that everything that could go wrong apparently did go wrong and resulted in loss of life. And quality, it really is meeting or exceeding the customer's requirements or their expectations. And that really means that the product or service really fits the customer's use. But equally important, it's adding value, and they perceive that value and they're willing to pay for that value. In this fitness for use is related to the benefits received by the customer and to the customer's satisfaction. And it's only the customer, not the producer, who can determine that. So it's really about the customer who determines what quality really means, because at the end of the day, that's who we're providing that quality for. That's the reason why we're doing it, to ensure that the customer satisfaction is high. But even with customer satisfaction, that is kind of a relative concept, and that it's going to vary from customer to customer. Most of our customers may be satisfied with our product, but tomorrow may be completely dissatisfied with our product. So it's one of those things that quality is something that should be striven or strove for, or we should be driving toward each and every day in what we do. And again, the quality of a product or service that's meeting the specific needs of a customer really is going to be judged by the customer. Not me, not you, not someone in management, but really is going to be judged by the customer. Interesting concept. And we are certainly in a consumer-driven market today, more so than we ever have been. What are some of the dimensions of quality over on page 164? Those dimensions or quality of design, quality of conformance, the abilities, and field service. And this is where quality now becomes more formal when you talk about these 4 dimensions of quality. So when we think about quality of design, is to determine before a product is even produced. It's usually the responsibility of a cross-functional team. That team may include marketing, engineering, operations, and other functions. That part of that design certainly can be determined by quality management or market research, looking at the design concept and the specifications. It is really looked at trying to determine what are the customer needs or assessing those customer needs. And they may do that in multiple arenas where they're doing market research, sending out surveys, actually asking the customer specifically what they want. Quality of conformance means that they're producing the product to meet the specific specification that's been determined by the design team. And when that product conforms to those specifications, operations considers it a quality product regardless of the quality of the design. If you think about that just for a moment, the quality of conformance means that we're forming to the quality design. If that quality design, even for inexpensive product, but if it has high quality as perceived by the customer, then it may have met its design criteria. So the quality of the design and quality of conformance represents 2 different uses of the term quality. So that's an interesting concept as well. And then when we think about the availability defines the continuity of service to the customer. In that availability is in an operational state. It's not down for repairs. It operates as designed. It has operational readiness, and that availability can be measured, as we see here, as the availability of the uptime divided by the uptime plus the downtime. So that availability really determines, it is a quantitative measure of how effective our design is because the equipment runs the way it's designed to run. So reliability, here it is. Reliability is how useful the length or how useful that product is going to be before it fails. Or another way to look at that is what's its runtime before failure is another way to look at that. And then we have the maintainability is how we restore product or service once it has failed. What's the mean time to repair? And that certainly plays into the fact of how close your service, your after service to the customer, the quality of that service, where your repair places may be, what's the process that a person will go through to contact and get repairs, and how those repairs scheduled and implemented in a timely fashion. So that's the maintainability, to return it to a service as quick as we possibly can, which goes into the field service aspect, and that which is the last dimension of quality. And that really represents the warranty and repair or replacement of the product after it has been sold. After service customer, after you sell a product, good, or services, how well you provide after sales service is paramount in determining the quality that is placed on that product or service by that customer. And when we look at, there's 4 different types of quality. Again, we have this figure over on page 166 that goes into these 4 different qualities of customer satisfaction that plays into that. And again, those were quality of design, quality of conformance, the availability, and the field service associated with that. And when you think about the quality aspect, the service quality, also on page 168 comes into play. Well, the service quality is different from that of manufacturing quality because service quality has the dimensions of good, tangible, explicit service, or psychological implicit service. And what this is not manufacturing a product, but this is providing a service to a organization. But even with that, we have the reliability, the responsiveness, the assurance, and the empathy that we show to our customers as we move forward in dealing with service quality. And those these five attributes that we see here really goes into this concept of how we measure service quality called ServQual. And ServQual is the assessing customer perceptions is most popular way of evaluating customer perceptions over these five dimensions of the tangibles: reliability, responsiveness, assurance, as well as empathy. And as you can see over on page 168, we have this figure that talks about these concepts and how these concepts are used to ensure that the customer quality needs are met. And you see on this dotted line are those attributes. The customer does have a voice per se, but a customer is not really involved in that, because this is really what the company itself is doing, not the customer. Now, the customer may have a voice, which is what you want to see. And if you've ever studied Amazon, you'll see that Amazon relies heavily on customer feedback as they improve their after-sales service. So let's go back over to page 168 just for a few moments when we talk about ServQual again. And we look at that, we're talking about the five dimensions. The tangibles, it really is about the appearance of the physical facilities, equipment, and personnel from the firm and how they're representing that company when they interface with customers. The reliability deals with the ability of the service to perform a promised service, dependability, and without errors. Even in the service business, you want to be sure that you're on time. And I'm sure you have examples just like I do where I've called customer reps or had waiting for someone to come do a warranty repair, and the time they said and the time that they actually arrived were in some cases different, which if you have to stay at home waiting for them to get there, I'm quite sure that you felt some of that pain, and your view of their service quality would be different. The responsiveness, how willing the service firm is to provide a service that is prompt and that is helpful to the customer. That helpful to me, equally important, also means that the issue that the customer had has been solved. And that it's solved to a point where it's not continually repeating, causing rework or recalls back to that customer's location. And the assurance, the knowledge and the courtesy exhibited by the employee, that their ability to convey that you can have trust and confidence in our skills and abilities to take care of you, because we recognize that we want you for a customer for life, not just a one-time customer. And then empathy, showing that you really, really pay attention to the customer and that you really care and have concern for that customer and recognize that customer, if they are for a for-profit business, that downtime of that equipment or whatever it may be has a direct impact on their bottom line. So you do have a sense of urgency, or displaying a sense of urgency, to get their equipment back up and running. So that's the service quality. Then over on page 167, we go into the quality planning and control. And this is where this quality cycle comes into play in figure 8.2. And it's really looking at the customer needs, how they are determined. It's typically determined through marketing functions, because the marketing is going out and doing their marketing research. Then that information is then handed off to the engineering department, who's taking that information that they received from the research and coming up with a design with specific specifications. And those specifications hopefully are going to meet the demands and needs of the customers, and they define their quality characteristics of that particular product or service. Then those specifications are actually passed off into the operations, where operations must continue to ensure that the product is produced as specified, or if it's a service organization, that that service is provided in a way that's going to meet the customer's needs. And then we have the quality control, and the quality control is truly where the entire process is looked at to ensure that quality is built into the process and not an end result inspection of the process. And then as you think about another example, here's a quality cycle in mass transit at page 168, figure 8.3, which kind of takes that concept and put it into an example of a mass transit system. So the implementation and planning, control, and improvement of quality goes through a quality cycle requiring numerous steps. And some of those steps, again, are defining what the quality attributes are for the customers based on their customers' needs. And this is where that market research is coming into play. Deciding how to measure each attribute. Key performance indicators, absolutely paramount. You have to pay attention to them, because what gets measured gets treasured, and what your boss finds important, you should find utterly amazing, because that's where you're going to be devoting a lot of your time and efforts to as an organization. So you want to make sure that you decide correctly on what attributes of that process you want to measure, because that's where a lot of your efforts will be spent. Setting the quality standards, establishing the appropriate tests for each standard, and finding correcting causes of poor quality at the very beginning, not just a surface identification, but truly eliminating those causes of quality. And as any good organization, you're continuing to make improvements in the entire process. So that's it. You see that over on page 168, 169. And on what measurement techniques to use, you have to set some type of quality standards that describe the amount of quality required on each attribute, and they typically have a plus and minus tolerance range. And there's multiple examples with reference to that tolerance that we'll see here in a moment of how we go about doing that. And it's not simply enough to inspect the products for defects, but it's more important that you cannot inspect quality into a product. You got to build it into the product. So a better approach is to identify the errors from occurring from the first place, get them identified and get them corrected, where they don't continue to be a thorn in your organization's side. It's really about identifying the errors, and that identification may come through the way you train your employees, even in the quality controls that you have with the people, your suppliers, who are providing you with goods and or services as well. But it's really about getting down to the root cause of why you're having quality issues or rework issues, multitude of reasons, and getting those issues resolved once and for all. And it's very important for the robustness in your processes in your system, that as people change, as technology is changing, understanding that and building that into those processes, so that when those changes occur, it continues on, and we're not dependent on, say for instance, one single individual who's going to maintain quality for us. Now, over on page 170, this concept of mistake proofing, developed back in 1960s for Toyota Motor Company, is called Poka-Yoke. What it's really about is mistake proofing. In other words, it's an idea of designing the product and the process that is basically impossible for humans to make mistakes, or for mistakes to be easily detected, or for the mistakes to be easily detected when they do occur. Interesting concept. Poka-Yoka, again, over on page 170. And if you look at figure 8.4, they gave us some great graphical examples of how we can mistake proof a product. But Poka-Yoka, part of this ensuring quality is not only in-house, but looking at suppliers and in the supply chain beginning over on page 171. And because a product may be complex, doesn't mean that we cannot ensure that our suppliers provide us with high levels of quality that's built into their product that comes to us as well. And we have this concept called rolled yield, which accounts for the cumulative defect rate observed by the final customer. And they give us this example, and this is a good example to make sure that you understand how it works. Excuse me. Here we have a product or service that has 100 components. And of those 100 components, each part has a yield of 99%. With a 1% being defective. So if we have 99% being effective, we have 1% defective. And the overall, what we want to do here is measure the overall yield of the final product, which means that we're multiplying the yields of all the individual producers. Since there were 100 producers with the same yield at 99%, in this case you can see it's just a multiplication or raised 99% raised to a power of 100, which gives us the cumulative rolled yield of 0.366. So let's say that we had another example where we had 10 components that had a 95% effectiveness rate, and all 10 components had the very same effectiveness rates, which means we have a 5% defective rate. So following the rolled yield example, we would have 0.95 or 95% raised to the 10th power because they're all the same, which gives us a rolled yield of 43.4%. So it's just a way to look at the final product and how we measure that final product based on the effectiveness of each component coming into that particular process. Another way to do this is certainly through supplier certification. Supplier certification of IS 900 really looking at how the supplier has control over its processes and whether it can withstand the audits of the ISO 900, which is an industry standard of quality. But that's supplier certification is certainly one way to overcome that. Some suppliers may not seem the need to understand or have the resources to which to develop a system that meets the ISO 900 standards. Certainly that's understandable, but depending on the type of manufacturing process you're in, you may not have a choice but use ISO 9000 type certifications in your supplier chain. But that's one way in which you can ensure that suppliers are building quality into the products that they're selling you, that you in turn are using those products to build your products, which goes to satisfying your customer needs. And again, customer satisfaction, excuse me, customer satisfaction is really in the eyes of the customer. Excuse me. How well they perceive the quality of that product or service being offered. Okay, over on page 173, talking about the cost, the quality cost, and the financial performance. In the area of quality, it is a great concept, great idea to calculate that cost of quality. That cost of quality includes prevention, appraisal, internal failure, and external failure categories. Not all inclusive, but as a benchmark or a baseline to which to springboard from. And the cost of quality may be broken down in two components, being control cost and failure cost. And the control costs are related to the activities that remove defects from the production stream, which can be done in two ways, by prevention and by appraisal. And the prevention costs include activities such as quality planning, new product reviews, training of employees, engineering analysis, and they should occur before production, which are aimed at preventing defects before they occur. The other cost is appraisal or inspections, and that's really aimed at eliminating defects after they occur, but before the products reach the customer. Then we have the failure costs, which is looking at those costs incurred while you're in the production process, was typically considered internal, or after the product is shipped, which is external, and your customers identify it for you. In some cases, the internal failure costs include items such as scrap, rework, quality, downgrading, machine downtime, where external quality may include warranty charges or warranty cost, the cost of returning good and allowances. And we have this figure here on 8.1, this table 8.1 on page 174, that really provides a very good snapshot of the difference cost of control cost and failing cost, and gives us a few more examples of the preventing cost, the appraisal cost, internal and external failure cost. Very good read, a very good reminder of this cost of quality as you think about how quality, there comes a direct cost to you as a business from poor quality. And this is, again, a good table to look at those different costs. This figure is figure 8.5 on page 175, and it kind of looks at the delta or the difference between preventive and appraisal costs and internal and external costs. As you can see, that if the product is defective, then it certainly has a cost directly to you. But if it's not defective, it also has a cost of great customer retention, great customer satisfaction. But it's just a different way of how you're looking at the cost of quality and how they can relate to one another. And as prevention and appraisal costs increased, internal and external failures decreased. And there's a trade-off that's going to exist between the control costs of preventing and appraisal and the cost categories. And this figure 8.5 suggests that there's an optimum quality level that may not be 100% perfect, but yet quality management stresses continuous improvement by finding ways to shift that curve for prevention and appraisal to the right over time, allowing quality to improve through more efficient and preventive appraisal activities. And that's what that figure is really trying to get us to see as well. This figure 8.6 is another graphical representation of how quality can contribute to profitability. Now, when we talk about quality pioneers, Edward Deming and Juan are two of the heavyweights when it comes to pioneering quality. And it really started with Edward Deming, who emphasized the role that management should take in quality improvement. And he defined quality as a continuous improvement of a stable system. He really emphasized two things. The first one, was that all systems, administrative design, He indicated that all systems, administrative designs, production, and sales must be stable in a statistical sense. And secondly, it must be continuous improvement of the various systems to reduce variation and better meet customer needs. And he developed the 14 points of quality at the bottom of page 177, table 8.2, which is a good concepts to always keep in your leader management toolbox. because it really goes into looking at how quality should be built into any type of service or production, with the mindset that you're not focusing on the short-term profits, quarterly profits, but you're taking as a leadership management team, even as a worker, looking at it from a long-term perspective. And he really stressed that top executives within the organization should be managing the organization for the long term and not sacrificing quality for short-term profits. But we know that at least we are driven somewhat by our earnings per share predictions and how our stock prices will vary based on whether we're meeting those targets or not. So it is a challenge for today's organizations to take a long-term perspective and not focus on the short-term profits. But Edward Demings is, when it comes to quality and the 14 management principles of quality, he is the gentleman who created all that. Very interesting read as well. Joseph Wan was another one. He was really originated the idea of the quality triology of planning, control, and improvement of quality. And he suggested that the company should identify the major business goals, customers, and the products required. And after they carefully test all of those, after carefully testing those, they want to make sure that they're meeting the customer needs. And he really stressed the quality of control through the use of statistical methods, as well as Deming, who believed that strongly that in the statistical approach to quality is a way of achieving process control. So both Deming and Wan really believed in statistical analysis, a statistical approach, a statistical goal or measurement to ensure that quality, again, is built into the very fabric of an organization and not an afterthought. Table 8.3, quality, changing quality assumptions when it comes to how we're going to get our organization to respond to building quality in everything we do. Very good insights here as well. Another one of those that you could stick in your management toolbox that may aid you in your career. Over on page 180, the operations leader when it comes to Physicians Clinic. One of the things that this particular organization did, and they were trying to get certification in ISO, they were motivated to do that. So that's a very good, interesting read as well. Well worth your time to read that, operations leadership. Then we have this thing called ISO 9000 standards, where really it's about certifying suppliers who are supplying those things for you over on page 179, 180. But it's really a industry worldwide organization, international organization for standards. It is really about building quality into the very fabric of everything, how a company should go about ensuring quality and understanding the benefits that goes just beyond building quality into everything that organizations do. But that's the ISO 9000 standards. Even some of your organizations may be even ISO 9000 certified. There's just a few examples. ISO 14000 is another set of standards of environmental management, environmental auditing, and it's also intended to help organizations improve their environmental performance. The Malcolm Baldrige Award is really an award that's given to those companies, typically 3 organizations in each 6 categories, as they're improving their quality. Very robust in order to get there. Table 8.4 on page 182 goes into, at that particular time, the categories and items and what they're looking for in order to ensure that those organizations who are being considered for the Malcolm Baldrige Award meeting that criteria. Here are again those categories for Baldrige Award: manufacturing, service, small, healthcare, education, and nonprofit. And they're looking at this particular these quality attributes when it comes to awarding a company the award. Why do some organizations fail to improve efforts, or why do they fail at quality improvements? Some studies have indicated that less than 1/3 of companies have attained or are successful in obtaining quality or significant results from their quality. And some of the reasons, it really, at the end of the day, begins with top management. Top management has got to recognize that to improve quality, it's got to change its values and its management philosophies, which we know is not going to be easy. All of our organizations has a mission, vision, value statements that we all have a chance to review periodically. We may even have them posted strategically throughout our workplaces, and that we probably roll our eyes over them almost every day and walk right past them and never really stop and pause and ask ourselves, or the organization pauses and even asking themselves, what do I do every day that aligns my job performance to ensuring that I'm creating values through my organization by meeting the mission, vision, and value statements of my organizations. It's more than just words on paper, because if it's words on paper, that's all it is. It's not internalized. And quality really is something that's got to be internalized from the top management all the way down to the shop floor, so to speak. Everyone within the organization has to internalize. That's an easy thing to say, but very, very, very hard to implement it. But the first step and again, the studies indicate that why some of these companies fail is because management fails to embrace the quality improvement concepts. Managers may continue to focus on short-term financial goals with the exclusion of any type of system improvement. They may blame others, especially the employees, and the employees may blame other employees or other work groups or other business units within the same company when there's a quality failure, and they fail to recognize, before I look at somewhere else, let me look internally to me, to my organization, to my team, to my business group, my geographical region, whatever the case may be. Some managers who may believe in trade-offs when they decide to skip or ship or fix a quality product. Again, those short-term results. Sometimes teamwork is non-existent. Sometimes we fail to ensure that our suppliers who are having quality issues, that we're working with those suppliers to help them resolve those issues as well. And again, it's not some suppliers are attempt to inspect the quality after the aspect, but we're helping them realize that they have to build quality into their processes, their mission, value, and vision statements as well, within reason. And the only way to institute a true quality is through an extensive education program, not only education of management, but every employee within the organization, because equality is about leadership at all levels of the organization, and how we take that quality leadership and have discussions with our suppliers again to help them improve their product that they're providing to us. So that concludes Chapter 8. Let's move on to Chapter 9. Chapter 9 talks about quality improvement, quality control and improvement. And these are some of the things we hope to talk about in this particular chapter when you think about control systems, how we measure some of those controls through control charts and variability charts, Six Sigma, Lean, and Six Sigma as well. So the design of quality control system really includes looking at breaking the systems down, in this particular example, into sub-processes. What is our internal customers? Who are our internal customers, and what product or services are they producing to ensure that the overall team, excuse me, or the overall organization is supporting each other. Then we look at this concept called what do we need, processes that we need controlled, called critical control points, that are those points where inspection or measurements should take place within that value stream. And at each one of these points that we're going to inspect, which really, again, it comes back to management, really understanding the process, and management working with their teams to determine at what point are we going to inspect at these critical points. And then the operator inspection is really preferred because it places responsibility on those who are making the product or services, or those who are actually knows the process better than those who are up in the ivory tower, so to speak. So this whole process is really looking at designing a quality control system to identify the critical points at each step in the process where inspection and testing can and should begin. And again, here's some of the critical points of incoming materials, the working process, and the finished product or services, deciding on what type of products or what type of measurements that we need to incur, and how much inspection is going to be used. I mean, certainly you're not going to inspect every product coming through an assembly line, or you're not going to inspect every service that you make to your customers, but what's a representative sample that you can use, so that when you do those inspections, you're getting a good snapshot of how good or how bad, or what areas need to be improved in that. And this design of a quality control system really begins on page 190 and goes through page 192. So good reading as we think about designing a quality control process. Two types of measurements when it comes to quality. Variable measurements was looking at a continuous scale of factors such as length, height, weight. It could be the dimensions of parts, the viscosity of liquids, the time it takes to wait on tables in a restaurant, as an example of a variable measurement. The attributes measurement uses more of a discrete scale by counting the number of defective items or number of defective units or defects per units. With this particular one, it's a little more complex because the quality specifications, and it may be you may have to use discrete measurements in order to do that. But that's typically the two types of measurements. The process of this quality control, beginning on page 193, is looking at how we go about controlling the process by utilizing inspection or testing of the product or service while it's being produced, so that we have the opportunity to stop and search and make an assignable cause. And that assignable cause, when we find something wrong, may be a change in the process, could be a resetting of the machine, or re-looking at the material, up to and including maybe even changing out the people who are actually operating the machine for a multitude of reasons. So this process can be brought to a state of control, and it can be maintained in that state using quality control charts, which we'll see here in figure 9.1, where we have our center line, excuse me, an upper control limit and a lower control limit. And typically, if you remember, if you remember from your statistical days, they're typically the upper and lower control limits are typically set plus and minus 3 standard deviations from the mean, with the mean typically being in the center line. But you kind of see that over on figure 9.1 on page 194 when it goes into looking at the 3 standard deviations, 3 standard deviations of the upper control limit, the center line, and the lower control limit. So that is a way that we can use quality control charts to help us determine if this is where we want to be, what's an acceptable out of tolerance upper and lower. And when we get either upper or lower, like we have here, understanding why, what caused this, assign those causes, then go identify what caused that, then correct those causes so that we can get back within our upper and lower limit. Hopefully we will correct this one time and correctly the first time, where we're always right here on the mean and not at the upper boundaries or the lower boundaries of our control limits. So these assignable causes has a multitude of reasons that cause us to fall outside of our control limits. And when we identify those control limits, what we want to strive to do is bring the process back under control without changing the design of the process, completely rechanging the design of the process, but making those minor corrections that's going to keep us within our control limits. And common causes, certainly, in some cases, we may have to redesign the process, but hopefully we can change it just enough to keep us here at a constant state of statistical control. Here is a example of a quality control chart of temperature and humidity in a museum, and you can imagine that certainly with historical documents why it's important to maintain the readings for that has an adverse impact, that if the humidity and the temperature varies a lot within that particular environment, the damage that it can control to irreplaceable documents. So over on page 195, we get into 195, 196, we get into the attributes of control, where we're using the P chart. The P value is computed for each sample, then the average overall samples to yield a P hat, and the P hat is used at the center line since it represents the best available true average measurements, and you see that particular formula again over on page 195, where you have an upper and lower control limit, and you can see that on page 195 it's the very same formula. The only difference is the addition or the negative sign for the upper control limit being plus 3 deviations of the average, and the lower control limit is being the negative 3 standard deviations of the average temperature and what we had earlier. So that's a good one to make sure that you understand how these control charts work. Then we have these variable control charts on page 196 when it comes to variable control charts, where we have the upper X chart and the R chart, where it's very similar when it comes to determining what's going to be the continuous variable, how we're going to inspect that variable. One is the central tendency and one is the variability of the process. And when we find that to be out of control on either one of these charts, again, we have to stop, understand what was the cause, assign an assignable cause to it, and ensure that we get the calls corrected so that we can get back to being on center line. So two different measurements when it comes to variable control charts. And they give us a great example there on page 196 and that attribute control of a P-chart example. So looking at the lower control limit and the center line and seeing how we actually go about using that calculations. So how do we go about using some of these quality control charts? It's really looking at if we have an observation that is that's outside the plus and minus upper and lower control limit of 3 standard deviations, and trying to determine if there's a pattern or a recurring trend that's occurring, why that trend is occurring, and what do we need to do to verify that trend and correct that trend so that we can get back to a standard state of operation there around center line. So it's really about measuring the process so that you can determine how effective that process is, find any areas that's causing problems and get those areas corrected. So there's multiple examples, multiple industries that use quality control charts to measure the effectiveness of the organization. And it comes down to how large the sample is going to be, how often to this sample, and what's the process control versus process capability. And it really, again, this is where the management team, with those who have their hands on the equipment every day, really needs to sit down with the design department who designed the specification to make sure that the organization can stay within its statistical controls. And it's really about, over on page 198, 199, looking at process capability, and then process capability, process control versus process capability is really about the process to meet or exceed the technical specification that was obtained from the customers, that was given to the design team who actually helped us design the process. And it's important to remember that whether or not a process is in a state of statistical control or whether or not a process is capable are two separate issues. Just because a process is in a state of statistical control does not mean that it's capable of maintaining that statistical control. Here's an example, figure 9.3 of that particular process, where we have the process capability with the CP, which is the process capability index, which is the ratio of the specific spec within the process width. We have the spec width divided by the process width. And in the center line is where the production range, in this particular example that we have here, is the center line. Here's that example of the process width and the specification width, and here's the center line. I kind of think of this as, this is my garage, this is my right-hand mirror, this is my left-hand mirror, and this is the width of my garage. And how can I get my car in that garage without tearing off my two mirrors is one of the examples that what it reminds me of. And depending on if I get too far to the right, where I'm drifting to the right, when I back my car out of that garage, I may have to make some manipulations to ensure I don't strike the side of my post to tear off my mirror. But it's really looking at the process width and the specification width. Just because I have a 8-foot garage door, an example, and my automobile from mirror to mirror is 7 feet 10 inches, or right at 8 inches, that even though I think I can get it in there, it may not be capable of allowing me to get in there consistently. So this is the process width, the process capability index, CP, spec width over process width. And we see that we have an upper control limit and a lower control limit. And here we're using 6 sigma or 6 standard deviations. And that, again, 3 standard deviations to the left, 3 standard deviations to the right, which gives me the process width of 6 standard deviations. And that's where that's coming from, over on page 199. And here is figure 9.4. Continuous improvement, figure 9.4 on page 200, which gives us a few more examples of those calculations as well. So understanding these calculations, I believe is important for you as well as you understanding this concept of quality control, process capability. And if the process is centered at specification range, CP, then it typically will equals 1, where the process is considered to be minimally capable of meeting the specifications. So for normal distribution, CP equal 1, the process is centered within the specification and under statistical control, or in other words, 6 standard deviations of 99.74%, which if you recall from your statistics, that equates to approximately 3 standard deviations to the right and 3 standard deviations to the left. But if you really want to think about this from this concept, if the CP is greater or equal to 1, it is, especially if it's greater than 1, it's a good indication that the process is able to meet its specification. And they kind of talk about that there again at the bottom of page 199. So as we continue on, we talked about this particular figure as well, which again, figure 9.4 at the bottom of page 200. Up at the top of 200, they give us that table 9.2, again, as give you an example of sometimes quality, when we say is good enough, really is not good enough, and they give you a few of those examples there. One of the problems with CP is that it requires the process to be centered, and because of this, they use a widely used measure, a widely used measure of CPK, or which is being devised by where you're taking the minimum of the upper value minus the mean divided by 3 standard deviations, and you are the minimum of the mean minus the lower standard deviation of 3 standard deviation. So you're looking at that. The CPK is really looking at those 2 variables of upper and lower and taking the minimum of the 2 calculations. And that's really all that it's saying. And the CPK is accurately reflects the actual process capability and is the measure commonly used by industry. So again, that CPK is taking the minimal value of those 2 variables. It's taking the minimum value of this one, of this one or this one. That's what the CPK is measuring. So again, on page 200. So continuous improvement. When a process is not able to meet customer specification, then continuous improvement initiatives have got to be looked at, because in some cases, not all processes can be improved. That's going to be improved enough to significantly change the process. But it is something that every organization has got to be looking at to ensure that they're striving to meet the ever-changing needs and demands of the customers, making sure that their specifications built into the quality of product for that customer. Over on figure 9.5 on page 201, they give us these 7 tools of quality control: flow charting, cause effect, check sheet, scatter, diagram, histogram, control charts, a Pareto chart. Whichever chart that your organization is using, It really should be used as a tool to aid you in identifying why you're out of process control, identifying the problems, and aid you in getting you back into process control and continuously monitoring that process so that you can find the causes and get those causes corrected. Flow charts. Here's just an example of the 7 tools used at a battery manufacturing. It's Pareto analysis that they went through to look at what was all the issues associated with that particular example. So this is the problem. This is a tool that they use, a Pareto analysis, to help identify what are some of the issues associated with that. And they created a Pareto diagram so that they could actually see what was the greatest cause. In this example, it was a result of loose connections. This figure takes it also in cause and effect of the wishbone, fishbone diagram, the cause and effect for the loose connections of this particular example. And if you think about that, over on page 202, 203, goes into that example where flowcharts can describe the relationship between the process and reveal unnecessary steps. The histogram is a frequency count using the data to form the shape of that, and a Pareto can be used to show the most important problems. So this is just an example of 2 or 3 of those different 7 tools of quality control that results in the cause and the effect diagram of figure 9.7 to determine what is wrong with the process and what that particular organization can do to go fix that process. So moving on page 204, we would go into Six Sigma. When we talk about what Six Sigma is, Motorola on page 205 is a very interesting example when it comes to Six Sigma quality, as you can imagine, manufacturing component parts for a multitude of Motorola products. But that Six Sigma is a systematic method for process improvement that uses the 5-step acronym of DMAC, as you can see, is define, measure, analyze, improve, and control. The process steps of DMAC, as we see here at the bottom of page 204. Six Sigma quality uses a team approach. A process is selected, a cross-functional team is going to be formed, and we see this over on page 207 in table 9.5 gives us a comparison of the Lean and the Six Sigma process and what each one, what are the objectives, what type of organization is required, what type of training, and what type of projects that can be used on. And you typically want to bring in a cross-functional team, those who understand the process, who probably work with it every day, who knows the issues associated or seen the bottlenecks. And certainly you want to have someone who is black belt qualified, or in this case, a black belt leader, someone who understands quality, who understands the tools that's going to be utilized, someone who could help direct the cross-functional team to continually ask, why is this occurring, why is this occurring, why is this occurring, to help that team come up with some tangible solutions to correct that why and hopefully improve the overall process. But it's really about using this method to determine what are the problems, what are the root causes, and in fixing that root causes so that the root causes are dealt with once and for all, and that the operation can continue to improve. And it's really about continuous improvement, not like education. Education is a lifelong pursuit. Well, quality improvement in an organization is a lifelong organizational pursuit as well, because if you're not improving, then you're losing ground because your competitors are. Lean and Six Sigma. Again, table 9.5 on page 207 goes into a lot of differences of this type of information here as well. Okay, so that really concludes Chapter 9, Chapter 8, and Chapter 9 for this week. Hopefully that was beneficial to you, and we look forward to our next two chapters. Thank you so much.